1, 2, 3. That was very exciting. I don't seem very excited about that. 1, 2, 3.
Happy Mole Day!
Say happy Mole Day.
Happy Mole Day!
Anybody else? Good hand. Garrett? June 2nd, right. Now Michaela said June 22nd, but it's 6.02. So it's June 2nd. Now we don't typically celebrate Mole Day June 2nd because most people are out of school. Like last year we got out of school May 25th, so we weren't in school that day. So most people celebrated on October 23rd. So, you know, that's just the day that people decided to do. Now this week is really special for chemistry. It's like National Chemistry Week. Now, when I started teaching, every textbook has a lab that they send with it. That is activities for you to do in the lab. Well, the problem is back in 2012, OSHA came out with some new guidelines, and the guidelines are associated with the chemicals that are out on the table. And it says that every chemical must have the name, address, product identifier, signal word, hazardous supplemental, precautionary supplemental, and they pictograms. So these lab aids come with all that. They have the signals on there, danger, precautionary statements. You're also supposed to have, with every lab, the safety data sheets, which are right here. In case something happens, they have to be on hand. So I have to print these out for every chemical that I have out, right? And they have to be up to date too. Cesium 137. Right, now why is Cesium 137 significant? And it's been in the news in the last couple of years. Anybody? Remember the earthquake in Japan? Right, there was an earthquake and it sent a tsunami and it knocked out the nuclear power plant at Fukushima. And at that plant, when it melted down, there were a couple isotopes of concern, namely iodine 131. Now iodine obviously is an important part of your what? Iodine can be found in your thyroid. And what does your thyroid do? Regulates metabolism, fights disease, things like that. Make sense? All right, so the second one is cesium. Now we have our bell work on the board there, cesium 137, right? So cesium, why is cesium significant? What does it do? Well, if you look on the periodic table, you'll see that cesium is found in the same group that sodium is found. Same family, right? So, if you ever heard of the sodium-potassium pump, you had biology last year, you should have heard of that. Sodium-potassium pump, what does it regulate? What does it pump in and out of your cells? Basically water. So the sodium-potassium pump is responsible for water regulation in and out of your cells, right? So sodium is very important. Now the problem is that cesium can mimic sodium. If you get cesium in your body, it's going to knock sodium out. Now you got the cesium there. And the cesium 137 is radioactive. What does that mean? You will die. It emits radiation. It's going to emit things. Specifically, what's it going to emit? Alpha particle. It's a very large isotope, 137. It has an atomic mass of 55, so it can emit things other than alpha particles. Right, so cesium, it's going to stay around for 30 years is the big problem. You get it in your body, it's not going away, so it's going to cause problems for a long period of time. So let's take a look at this half-life problem.
That's just a half-life.
Right, so what's your final number?
0.125. Cody's got it. Nope, did it wrong. Did I? 27.
Put it on there.
Yeah.
Yeah, equals. Well, put it down there.
Where?
Underneath it. Bell work. What is the mole? Adam? Right, so the mole is a very important number because we use it to determine what we have. If you remember, when we were examining the atomic mass unit for hydrogen, right?
Yep.
That's what Dalton did first. And then we switched over to carbon because it's a solid and it's not diatomic. But from that, we used, what did we use to calculate the mole? Remember, we've already talked about this. We used two things to calculate the mole. The Faraday constant, remember Faraday constant, was the amount of electricity it took to make a mole of silver. And how'd they get that number? Well, they just took the AMU for hydrogen divided by itself, and you got a standard. You have a certain amount based on your standard. And then we needed to know the mass of the electron. How was the mass of the electron determined? Remember the experiment for that? Remember the Millikan oil drop experiment? Now these are on YouTube, these videos that we talked about this, so you can go back and check it out if you forget. But the Millikan oil drop experiment determined the charge of the electron. And then from that, the Faraday constant, which is the amount of energy it takes to make a mole of a substance like silver, that would be the electrons. You divide the two and you get the mole. Now this was verified with carbon. They took diamond and they counted it, right? So the mole is basically a number of things, a specific number of things. When you're selling things, if you don't know what you sell, then people are going to take advantage of you. Make sense? All right, if you go in there like, what do you have today? Well, I don't really know what I have. It becomes a problem, especially when you start manufacturing things on a large scale. If you know what you're selling, people will cheat less. Right, Chris? Chris, I'm about to send you to the library. Chris? All right, so today is Mole Day, if you didn't know that. Why is Mole Day celebrated on 2 calendar days? So what is today? October 23rd, right? All right. So if you look behind you on the Mole Day, see how? Can somebody raise your hand and name the mole for us? The number. Cody, raise your hand. All right, Garrett.
6.022 times 10 to the 23rd.
So where are they getting Mole Day from in that number? Where's the Mole Day coming from? Right, all right. Adam, good job. 10 to the 23rd. Okay, Garrett, so you did two things wrong. You had the wrong number, and you didn't label the unit. So you want to make sure you understand that you're starting with grams, so you got in with grams.
Yep.
And there's a caret on the calculator. Try it again and see if you get this answer.
Between a nucleus and its component nucleons is called the mass defect. When nucleons combine together to form an atom, the energy corresponding to the mass defect is released.
Everybody agree with that? No, that's wrong. Excellent. Cesium-137 undergoes beta decay into barium-56-137, releasing an electron. Now, when you get cesium-137 in your body, let's say if you're by the ocean, right? Because Fukushima was by the ocean. So you get some fish or something in you, cesium-137. It has a half-life of 30 years. So over 30 years, it has a 50% chance of changing into barium. Is everybody clear? Now barium obviously isn't good for you, it's a heavy metal. But the thing it's going to do, it's going to release an electron right here. And this electron is going to affect what system in your body? Your nervous system. Your nervous system is an electrical system. That's not going to be good. Now cesium is going to go into your body where your sodium-potassium pump is. And what does that control? Controls the water intake and out of your cells. So you should have learned that in biology last year, the sodium-potassium pump. Now, which does cesium mimic? Does it mimic sodium or potassium? It mimics sodium because it's in the same family. Sodium and cesium are in the same family, so cesium goes right to where sodium would be. It's bigger. It's like, hey, I'm bigger than you, get out. And then it affects your body that way.
You multiply 6 point, because The exponent is 23 in the scientific notation.
Right, so it's 10 to the 23rd, right? So today is what?
The 23rd.
Right, so today is mole day. Now there are actually 2 mole days, right? What's the other mole day? Vance? What's that? Right, but what day would that be? June 2nd. Very good. Now what's the problem with celebrating mole day on June 2nd? TT? What's the problem with celebrating mole day on June 2nd? What? You have no idea? Vance knows. Right.
The rad and the rem are commonly used to measure doses. The rad, which stands for radiation absorbed dose, is a measure of the amount of radiation that results.
1, 2, 3. Happy mole day.
Is the most stable atomic configuration. Thus, it is possible to bind together 2 or more light
Material with a mass greater than a critical mass is said to have supercritical mass. Figure 24.17 shows the effects of mass on the
With proper safety procedures, radiation can be used in any scientific experiments.
Hold on. Happy mole day.
Are not generally radioactive. Nuclear fusion produces large amounts of energy. Fusion reactions produce more energy per unit of mass of fuel than fission.
So TT just read that you have to cool nuclear reactors before you can heat the water again, right? So the question is, what heats faster, cold water or hot water, Lily? Cold water heats faster. Does everybody agree with that? Raise your hand. Cold water heats faster? Christian? What do you mean you don't know? Come on, we're talking about water. You can't tell me I've never heated water before. Raise your hand. Does cold water heat faster? Raise your hand. Yes. So I have 1, 2. What? Hot water does what? Yes, hot water does heat faster. So what's the problem with like celebrating mole day on June 2nd? Jimmy? No. What's the problem with celebrating mole day on June 2nd? Raise your hand. Okay, what would be the problem though with celebrating mole day on June 2nd? Oh, you're close. Yeah, we're not in school. We're supposed to get out on May 25th. So on average, we get out of school before June 2nd. Now there's one year that we didn't, and we were into like June the 8th, and we were celebrating. Well, June 6th, and we were celebrating mole day in here on that day, June 2nd. Celebrate. Nice job, Jamie. Excellent. 10 points.
Scientists have determined that the mass of the nucleus is always less than the sum of the masses of the individual protons and neutrons that comprise it. This difference in mass between a nucleus and its
What eats faster, Rosebud? Warm water or cold water? Okay.
Cold water.
Cold water.
It has to cool it down before it can heat it back up. So yeah.
Everybody agree with that?
Yes.
No. Yes.
Yes. I agree with it.
All right, so here's the point, right? Warm water does heat faster. You can go home tonight and you can try it. Now they cool it. They cool the water because if you send it back in there warm, it could heat up too fast and blow up like a pressure cooker. So it's very dangerous to heat water too fast. Russia did this and it blew up. Chernobyl, yeah, not good.
Of energy per kilogram of tissue. The dose in rads, however, does not account for the energy of radiation. The type of living tissue absorbing the radiation or the...
Right, October 23rd, based on what?
Based on the poster in the back.
I don't know, it just says right here.
Based on the 10th power would be October to the 23rd, right? The exponent is 23. Make sense?
Zeros.
Now, what is the other day that Mole Day is celebrated?
October
June 22nd.
June, but what? Not 22nd.
June.
June what?
June 2nd.
June 2nd. Raise your hand.
Said it.
Noah.
June
Now, Noah, why don't we celebrate Mole Day on June 2nd very often?
Because it's holidays.
No, I'm talking to Noah. Noah. John. Noah, we're waiting for Noah. Why don't we celebrate Mole Day often on June 2nd?
Because it comes in summer holidays.
Yeah, because we're on summer break. Now, there was one year we did celebrate it. It was like we had to go to school because there was a lot of snow days, but normally we're not in school.
Fraction of 1 kilogram of uranium is equivalent to the energy released during the chemical combustion.
More strongly the nucleons are held.
Hand. Cold water. Cold water.
Cold water.
Cold water. Cold water. Everybody agree with that? What? Room temperature water. Right. Now go home tonight, put hot water on the stove and turn it on, and put cold water on the stove and turn it on, and see which one boils faster. Why don't we celebrate Mole Day on June 2nd?
Is that when they come out?
No, because we're not in school.
From a radioactive source. 2 units, the rad and the rem, are commonly used to measure doses. The rad, is that rad or rod?
Rad.
Okay, rad, which stands for radiation absorbed dose, is a measure of the amount of radiation that results in an absorption